Today we're going to be talking about arithmetic sequences. In these sequences, it is either increasing or decreasing by a certain amount. In here, we'll just call this value d. Now, this makes it so that an is equal to an minus 1 plus d, because d is the difference between these two numbers. This makes it so that a1 is equal to, and plus n minus 1 times d is also equal to an. This is only if n is greater than or equal to 2, because you can't exactly have an a0 or a minus 1, because unless it's stated in the problem, they usually don't exist. Now, an is equal to am plus, well, this is equal to n minus m times d, similar to this over here. Now, if variables a, b, and c are in an arithmetic sequence, this makes it so that 2b is equal to a plus c. This is because c minus b is equal to b minus a. By rearranging this equation, you'll get this over here. Now, if Sn is equal to a1 plus a2 to an, that means that Sn is equal to n times a1 plus an divided by 2. This is because by rearranging this over here, we can get this is also equal to an plus an minus 1 plus to a1. A1. By pairing these up together and adding these two equations, we can get that these are all paired together. However, we'll notice something. All these pairings will equal to each other. This is because a2 is equal to a1 plus d, whatever d is, and an minus 1 is equal to an minus d. By canceling these two d's, you'll get the same thing as this over here. Now, let's add these two together. We'll get 2Sn is equal to n times a1 plus an. The reason it's n over here is because there is a total of n pairs. By dividing both sides by 2, you'll get the same equation as over here. Lastly, an is equal to Sn minus Sn minus 1. This is because Sn is just equal to a1 plus a2 all the way to a1. And then subtracting that by Sn minus 1, it'll all cancel out except for an. And there we go. Today we're going to be talking about geometric sequences. In these sequences, they're divided by a certain ratio that we are going to call r. This value is multiplied or divided into different numbers. For example, an is equal to an minus 1 times r. That's what we'll be calling the ratio in this video. This value is also equal to a1 times r to the n minus 1 power. This is also similar to arithmetic sequences, which we discussed in our last video. Now, an is equal to am times, well, similar to arithmetic sequences, it is equal to r to the n minus m power. Now, if we have a geometric sequence with variables a, b, and c, we will get that b squared is equal to ac. This is because c divided by b is equal to b divided by a. By moving the variables of that equation, you'll get this over here. Sn is in geometric sequences is equal to a1 times 1 minus r to the n power divided by 1 minus r. Since Sn is equal to a1 plus a2 all the way to an, this means that Rsn is equal to a1r plus a1r squared all the way to a1 times r the n. This is because a2 is equal to a1 times r, and by multiplying another r, we'll just get this over here. Now, by subtracting these two equations, we'll get that 1 minus r Sn is equal to a1 times 1 minus r n. This is because a lot of things in this cancel out, and you're left with this over here. By dividing both sides by 1 minus r, we'll get that Sn is equal to a1 times a1 minus r to the n power divided by 1 minus r. The same thing that is over here. Now, there's another method of doing this, but to use this method, we have to remember that an minus bn is equal to a minus b times a to the n minus 1 power plus a to the n minus 2 power times b all the way to b to the n minus 1 power. Since we know that this over here is equal to a1 plus a1 times r dot dot dot, that means we can take a1 out and get a1 times 1 plus r squared all the way to r minus n minus 1. Now, this should look familiar because we can just put this right into over here, and we'll just get the same thing as over here. And that's it for geometric sequences. Or is it? Because we have this over here, where s to the infinity is equal to a1 divided by 1 minus r. This is true if you say that r is equal to, I don't know, 1/2. So if we put that in here, we'll get that S infinity is equal to a1, we'll just leave that be, a1 times a minus 1/2 the n divided by 1 minus 1/2. While 1/2 to the n's power, infinite power is obviously very, very small. It's almost close to 0. So we can just get rid of it, and we'll just be left with this over here. So that's why but this only works when absolute value r is smaller than 1. Otherwise, that r to the n power won't be equal to 0. And that's really it for geometric sequences.